Question 24. An object moving with a speed of 6.25 meter per second is decelerated at a rate given by dv by dt. Is decelerated at the rate given by dv by dt, where v is the instantaneous speed. That means v is speed at that instant. The time taken by the object to come to rest would be, okay. He has given object moving with the speed of u, initial speed of 6.25 meter per second, and he has also given dv by dt is the deceleration equals to minus 2.5 root v. And what is he asking? The time taken by the object to come to rest. Okay, rest means final velocity equals to 0. What is the time taken t for your object to be at rest? Because there is a deceleration and there is initial positive initially there is positive initial velocity, and because there is a deceleration, some alpha, obviously your speed will decrease, and at some point of time you have to come to rest. Okay, and if the deceleration continues to act, maybe you will again move in the backward direction. But in the question, he is concerned only about this particular instant where velocity equals to 0, and he wants how much time it has taken for it for the velocity to come to 0. So how do you solve it? Okay, you want v and you have v and t terms. So let me get an equation in terms of v and t. So that's how I'll try to solve. So I'll bring 1 by root v here. dv equals to minus 2.5 dt. And here I'll try to apply integration on both sides. Integration on both sides. So you get integral 1 by root v dv equals to minus 2.5 integral dt. Okay, so integral 1 by root v dv. So as we know, integral x power n dx equals to x power n plus 1 by n plus 1. Similarly, integral v power minus 1 by 2 dv equals to v power minus 1 by 2 plus 1 by minus 1 by 2 plus 1 root v into 2. So this is how you get the value of 1 by root v dv. So that equals to, you can write root 2, that equals to 2 root v. Now you have to write the initial and final condition. So initial velocity is u, final velocity is v. Whatever variable we are having with d, so you have to write its initial condition and final condition. Okay, so minus 2.5 dt is delta t, integral dt is t, and initially at time 0, and maybe at time t the velocity will be final velocity. So this is how you write, and then you kind of elaborate. The meaning of this is substitute the final limit minus the initial limit equals to minus 2.5 into final limit is t, initial limit is 0, so you get minus 2.5 into 2. So 2 into root v minus root over 6.25 equals to minus 2.5 into t. By the way, the final velocity will be 0 because the object you want to find time when the object comes to rest, that means your final velocity is 0. So you solve it, minus 2 into root over 6.25 equals to minus 2.5 into t. Minus minus cancel, so you get t equals to, maybe if you square on both sides, t square into 2.5 whole square equals to 4 into 6.25. 2.5 whole square is equal to 6.25, so t you get as 2 seconds, and this is your answer. T equals to 2 seconds.